In this video, we're going to be looking at how to graph a quadratic function in vertex form. We are just coming off of a unit on absolute value where we saw y equals a times the absolute value of x minus h plus k, where we found the vertex to be the opposite of h and then k. And we're going to translate what we found with absolute value to what we can see here with a quadratic. We see that we still have the same variables, all basically in the same order. The only difference we have are parentheses versus absolute value bars, and then we do have an exponent, that is the square. That exponent, as the square with that 2, represents, that is what's going to tell us that yes, we are indeed working with a quadratic. That's our clue. The vertex of a quadratic in vertex form is going to be exactly what we saw with the absolute value graph, where we will be taking the opposite of h and then k. So if h is negative 2, this would be a positive 2 and then k. If h was 3, positive 3, then the vertex here would be negative 3, and k would stay the same. The axis of symmetry is always our x value, so our axis of symmetry, 2, would be the opposite of h. So let's see how we graph this. The first thing we need to recognize is that a quadratic makes what we call a parabola, very soft curves, as opposed to the absolute value that has very strict lines, straight lines. So when we go to graph this, we're going to make sure that we have our curves going and not straight lines. So we first recognize the vertex. We see this to be negative 2, 5. Axis of symmetry is going to be when x is negative 2. And so we have that, so we can go ahead and graph. We always start when we graph, starting with the origin, go left 2 and up 5, and I put my first point. Then we're going to make an XY chart, plugging in values surrounding the vertex. And I'm going to label that as the vertex with a V. And I'm going to have a few points below and a few points above. So negative 3, negative 4, and negative 1 and 0. I will plug in. It doesn't matter which one. I'll start with the negative 1. So negative 1 plus 2 is a positive 1. 1 squared is 1. 1 plus 5 is 6. You may also put that into your calculator. Plug in 0. 0 plus 2 is 2. 2 squared is 4. 4 plus 5 is 9. I go to the negative 3. Negative 3 plus 2 is negative 1. Negative 1 squared is positive 1. 1 plus 5 is 6. Well, look, we've got the same value going here. Negative 4 plus 2 is negative 2. Negative 2 squared is 4. 4 plus 5 is 9. And those are the same as well. So let's now graph off of our, knowing that that's our vertex. So we can go negative 1, up 6, 0, up 9. To the left, we can go negative 3, 6, negative 4, 9. And we connect those dots again. We don't do straight lines like we would with absolute value, but we make it curved and arrows on the end representing that it does go on for infinity, to forever. We notice that our A out in front is positive, so I do know that this graph should be going up, and that is in fact what it is doing. There is a shortcut in which we can find our graph by not having to do a complete table like this. What I want you to recognize, and I'm going to write down our squares. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. I think that's enough to get us a good understanding of what's going on here. And then what I'm going to do is I'm going to find the difference between each of these perfect squares. So the difference between 1 and 0 is 1. 4 and 1 is 3. 9 and 4 is 5. 16 and 9 is 7. 9, and that difference is 11. And if you notice, I'm counting by my odd numbers. 1, 3, 5, 7, 9, 11. And if you go back to what we just graphed, if I go to the vertex, I locate the vertex at -2, 5. And then if I go up 1 over 1, I get to my second point. The next difference is 3. So at this point, if I go up 3, 1, 2, 3, and over 1, I am at my second point. And if I would continue this at this point, if I went up 5, if it was on the graph, 1, 2, 3, 4, 5, and over 1, that then would be my next point. And I'm counting by odd numbers each time that I do that. And I would then reflect that over the axis of symmetry. That's why we find the axis of symmetry, and find the symmetrical point off to the left. Looking at the second one, I see that my A is negative, so I know this graph is going to be pointing down. My vertex is, H is 3, -3. I'm going to say that is opposite of that, so I'm going to say +3 and 4. Axis of symmetry is going to be at 3. So utilizing the shortcut, I'm going to go over 3, 1, 2, 3, and up 4, 1, 2, 3, 4. I have a slope of -1, so instead of going up 1, I'm going to be going down 1 and over 1, down 1 and over 1, and then from this point I can go down 3, 1, 2, 3, and over 1. I'm going to go down 5, 1, 2, 3, 4, 5, and over 1. And then again, I can reflect these points over to get a nice parabola without using my T-chart. We can always go back and make sure that I have accurate points. So let's just pick 5, for instance, and let's just plug it in and see. 5 minus 3 is 2. 2 squared is 4. 4 times -1 is -4. -4 plus 4 is 0. So I go over 5. 1, 2, 3, 4, 5, 0, and that is accurate, so that checks. So it's always a good idea, if you use the shortcut, to plug in a point just to make sure you're on the right track. Look at number 3. I see here that I have A that's not 1, and I have an x squared. What's missing is my set of parentheses. If that's a little confusing to you, go ahead and plug in your parentheses, including your h. So I see, because nothing is there, that my h is 0. So I have 0, -4 is my vertex. My axis of symmetry is going to be also at 0. So I graph my point, 0, 1, 2, 3, 4. There's my vertex at 0, -4. And now that my slope is 2, what I'm going to have to do is on each one of these, I'm going to have to multiply that by 2 and still then go over 1. So instead of going up 1 over 1, that 1 that I normally would move is going to be multiplied by that 2. So I'm going to go up 2 over 1. Now normally I'd go 3, but because my A is 2, I'm going to go up 6. 1, 2, 3, 4, 5, 6, and over 1. And then I'm going to reflect these points off to the other side of the axis of symmetry, and then I can draw in my parabola. I'm not the best at the parabola drawing, but you're going to get the idea. And number 4, I have a -a. That means my graph is going to go down. That is 3. And so here I see that I do have an h, but I do not have a k. So I will put in a 0 for that. So my vertex will be 5, 0. Axis of symmetry is at 5. So I go over 5, Do not go up or down, as that is my vertex. And utilizing my 1, 3, 5 shortcut, each one of those is going to be multiplied by 3. So instead of going up 3, I'm going to be going down 3. So 1, 2, 3 over 1. And then the next time I'm going to multiply by, this 3 is going to be multiplied by that 3, so I'm going to go down -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, and over 1. There we go. Reflected over. And I have my points for my new graph. And again, always a good idea to check with the t-chart to make sure that you have a point that you can verify as you go through. Vertex form is called vertex form because it is easy to pull out the vertex.